Let's take a look at dividing fractions. First of all, before I show you the trick for doing so, I want to explain why this works or what we're doing here. If you have two of something and you don't want to divide it into fourths, pretend that they're cakes. Let's just say, here I have two cakes and I'm going to divide each one into 4 equal parts. I have 1, 2, 3, 4, 5, 6, 7, 8 equal fourths. So we're going to come back to that because the only trick for dividing fractions is that your first number stays the same. Now I put this over 1, but that has the same value. 2 is the same as 2 over 1. When you divide fractions, you change your division to multiplication and you find the reciprocal of the second fraction. And so 1/4's reciprocal is 4 over 1. Reciprocal just means that the numerator and denominator switch places. And so then we just have a multiplication problem, and hopefully you've had these before. When you multiply fractions, it's simply numerator times numerator, get your answer, denominator times denominator. So in this case, our answer is 8. 6 divided by 1/2. 6 is the same as 6 over 1. We change our division to multiplication and find the reciprocal of the second fraction. 6 times 2 is 12, 1 times 1 is 1, your answer is 12. On this one, 5, 6 stays the same. Change division to multiplication. Find the reciprocal of the second fraction, which is 3/2. In this case, you can see that I did a little bit of simplifying or reducing within the problem before I multiplied. 3 and 6 are both divisible by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. The reason I can do that is because when you're multiplying, and we've changed it to multiplication now, you compare any numerator with any denominator and divide them by the same thing, and you're not breaking any math rules. So 5 times 1 is 5, 2 times 2 is 4, and 5 divided by 4 is 1 1/4. 1 1/4. 1/3, we leave that one the same. We change our division symbol to multiplication. Now, I had 8 here. That was the original problem. I wrote it real quick over 1 so you can see that 8 is the same as 8 over 1. So the reciprocal of that is 1/8. And when you multiply it out, you get 1/24. Let's take a look at just a few more. Here I've introduced some mixed numbers, and hopefully you know that when you take a mixed number and turn it into an improper fraction, which is what you need to do before you multiply or divide fractions, 2 times 1 is 2, and 1 more is 3/2. For now, I'm simply rewriting the problem. So I went ahead and copied the division symbol. 4 times 1 is 4, and 3 more is 7, so 7/4. So now I have it as an improper, and I'm ready to apply that rule. 3/2 stays the same. Change division to multiplication. Find the reciprocal of the second fraction. To make your work a little bit easier, I'm going to reduce or simplify it right now. 2 divided by 2 is 1. 4 divided by 2 is 2. You compare any numerator with any denominator only when you're multiplying. To simplify here, 3 times 2 is 6, and in our denominator we have 1 times 7, which is 7. For this one, 15, 16, 17, I'm going to have 17/3 times the reciprocal, which would be 4/3. Actually, there is nothing there that can cancel. So I'm going to come over here very quickly and take 17 times 4, which is 68, over 9, and 68 divided by 9 is 7 5/9. For this one, I'm going to start just by turning this into an improper fraction. So 6 times 4 is 24, and 1 more is 25. So I'm going to have 25 over 6. So I've rewritten this as an improper. Change your division to multiplication and find the reciprocal of 10. The reciprocal of 10 is 1/10 because 10 is the same as 10 over 1. Here, 10 and 25 are both divisible by 5. 10 divided by 5 is 2. 25 divided by 5 is 5. Numerator times numerator, and denominator times denominator.